this video will help you how to approach a complicated utility maximization problem like this. So I have taken this utility function from a question given in ISI PV 2015, and I want to find out the demand function for x1 and x2. Okay, so there are two ways of doing this utility maximization problem. One is your usual indifference curve method, where you are drawing your you're drawing your indifference curve in this xy plane. Okay, xy plane, and from that you are finding out your optimal bundles like that. Okay, so one bottleneck that is present in this approach is, let's say I want to draw the indifference curve, right? This is our utility function, and let's say nu is our utility level. Okay, and for this utility level I want to draw the indifference curve. Okay, now for this you can see that this might become a bit complicated to plot. Okay, so we have been given this, right? So x1 is equal to 3 by 2 x2 squared minus 16 x2 plus mu by 2. Okay, so this is nothing but a parabola that looks somewhat like this. Okay, so this might get a bit complicated to plot. Then after that you need to check all the corner points. How is the budget line's slope is basically compared with the slope of the indifference curve in these corner points. Okay, so it might get a little messy. The other way which I will be focusing on in this video is converting the utility maximization problem into a single variable. Okay, this is my objective today, right? So I'm writing the utility maximization problem once again here. So 2x1 plus 32x2 minus 3x2 square subject to p1 x1 plus p2 x2 is less than equal to m. Okay, and xy belongs to r2 plus. Okay. Now just try to think like this. Okay, in the optimal bundle, will this condition ever hold true? p1 x1 plus p2 x2 is strictly less than m. Will this function hold in the optimal bundle? It will not. Why so? Because if, let's say, there is an epsilon amount of income which is being left out, right? And if I put this entire epsilon into x1, okay, then you can see that our utility will go up, right? So I will try to not waste or leave any money on the table. Okay, whatever income I have, I will just put everything into purchasing x1 and x2. So in the optimal bundle, this will never hold. Okay, so in the optimal bundle, this has to hold every time. Okay, now with this condition, I will be converting the utility maximization problem into a single variable. Okay, so I can write it like this. So x1 becomes m minus p2 x2 by p1, and then I will maximize it. Okay, so 2 times m minus p2 x2 by p1 plus 32x2 minus 3x2 square. Okay, but still we have a constraint. What is that? That is our x2 will be between 0 and m by p2. Okay, since the least I can have of x2 is obviously 0 and the maximum is m by p2. So this is your constraint. Okay, now I will do our normal differentiation, which is I will differentiate it with respect to x2, and I will get minus 2p2 by p1 plus 32 minus 6x2. Okay, so this is what I am getting after differentiation. Okay, now I will plot this. I will plot this in the in in a graph where in the x-axis I will write x2, and in the y-axis I will have our slope of the utility function, or I can write it like this, that u dash, which is a function of x2. Okay, so in the y-axis I will be plotting this. Okay, this function. So this is nothing but our u dash x2. Okay, okay, so if let's say that x2 is equal to 0, then our u dash x2 is what? Minus 2p2 by p1 plus 32, right? Now this value can be either positive, it can be equal to 0, or it can be strictly less than 0, with depending on whatever the value of p1 and p2 is. Okay, and our slope of u dash is negative. Why? Because the coefficient of x2 is minus 6. Okay, so if I increase x2, u dash x2 will go down, right? So it will be downward sloping. Okay, but the intercept, which is this, will depend on p1 and p2. Okay, so let's start with the easy one. Let's say this intercept, which is minus 2p2 by p1 plus 32, it is strictly less than 0. Okay, which means I'm starting from, let's say, somewhere around here, this point. If I increase x2, u dash is falling like this. So what will be my optimal x2 bundle? Sorry, optimal x2. Okay, if I increase x2, u dash is negative. This is the negative space, right? This is the negative quadrant, and this is positive. Okay, so if I am increasing x2, u dash is negative. Since u dash is negative, the utility will be going down. Okay, so the best case scenario for me will be to save whatever utility I have by consuming x2 equal to 0. Because if I increase x2, my utility is falling since u dash is negative. Okay, so it's better that I consume nothing of x2. Okay, so if this is the condition, then the demand for x2 will be 0. Okay, Similarly, with our budget function here, which I've converted it into this, okay, with that I can find out what x1d will be, okay, which will be equal to m by p1. Done. Now if this minus 2p2 by p1 plus 32 is equal to 0, then in this case our u dash will look somewhat like this, okay. So again we are running into the same problem. If I increase x2, u dash is becoming negative, and since u dash is becoming negative, utility will fall. So again the best case scenario will be that I consume nothing of x2, okay. So again x2d will be equal to 0 and x1d will be equal to m by p1, okay. Now comes the interesting part. When minus 2p2 by p1 plus 32, this is strictly greater than 0, okay. Now let's see what is going on. So this is our intercept, let's say, and we know that x2 is between 0 and m by p2, right? Let's say m by p2 is somewhere around here, okay. This is our m by p. If let's say our u dash function can look like this, or it might look like this. So we have two cases, okay. What are the two cases? The first case is our u dash is intersecting 0 before m by p2, and the second case is u dash is intersecting 0 beyond this m by p2, okay. If u dash is intersecting m by p2 before, sorry, so u dash is intersecting 0 before m by p2, okay. So in that case, let's say that we are moving from x2 equal to 0 to the right hand side, okay. What is going on? When x2 is equal to 0, our u dash is positive, okay. We are slightly increasing x2, and since u dash is positive, utility will go up. So my job will be to increase x2 till the point where I reach u dash equal to 0 at this point, okay. Beyond that part, so beyond this point of x2, if I go, then u dash will again become negative and utility will fall. So my optimal bundle will be this, where u dash is equal to 0. So when this is the condition where the intercept is strictly greater than 0 and u dash x2 is equal to 0 before m by p2, then I will be consuming this bundle, okay. What is that bundle? Let's try to calculate. So our u dash x2 is this, which I have written here, okay, this one. Let's try to find that out, okay. So minus 2 by p2 divided by p1 plus 32 minus 6x2, right? Yes, minus 6x2, okay. This is equal to 0. So minus 2p2 by p1 plus 32 equals 6x2. So x2 is equal to 32 by 6 minus P2 by 3P1. Okay. If this bundle, let's say this bundle is x2 star. Okay. If this bundle is less than m by P2, then my demand will be this bundle only. X2D will be equal to x2 star. Okay. But if x2 star is greater than m by P2 or greater than equal to m by P2, okay, if it cuts the 0 point beyond m by P2, then my optimal bundle will be nothing but m by P2. Why so? Because that is the constraint, right? This is my constraint. I can't go beyond that. Even though I want to go beyond that, but I will not be able to because I have been bounded. Okay. So I'm again starting from this where I am consuming nothing of x2. I am moving towards the right since u dash is positive, and since u dash is positive, utility will go up, and I will be going up to this point. Okay. So if this is the case, then x2d will be m by p2. So what will be the demand function of x2d? Sorry, so what will be the demand function of x2? So let me write it clearly. Okay. If this, okay, so if minus 2p2 by p1 plus 32 is less than or equal to 0, then x2d will be equal to 0. Okay. If minus 2p2 by p1 plus 32 is strictly greater than 0, and this condition as well, this x2 star, I'm not completely writing what x2 star is. This x2 star is strictly less than m by p2, then x2d will be equal to x2 star. And the third case is if minus 2p2 by p1 plus 32 is strictly greater than 0 and x2 star is greater than or equal to m by p2, then the demand for x2 will be m by p2. Similarly, I can find out the demand for x1d by plugging these values into the budget equation. Okay. And the conditions, these three conditions will still remain the same.